In this video, we will be talking about Miura's load study program. What is a load study? A load study is an analysis of a potential customer's steam demand. We install sensors on their existing boiler to continuously monitor the firing rate. Using this information, we attempt to identify the maximum and minimum steam demand for their system. It is important to note that a load study is not an efficiency study. We are not trying to measure the efficiency of the customer's boiler. Instead, we are only trying to determine the actual steam demand. Why do we perform load studies? The purpose of the load study is to better understand the customer's steam demand. Using this information, we can better size a Miura steam solution to meet their needs. Many customers do not have dedicated gas meters or steam meters, so they actually have little idea how much steam they actually consume. Traditionally, fire tube boilers were significantly oversized. This may have been justified for a number of reasons, but at Miura, we are interested in sizing the system to meet their actual steam needs. For example, assume a facility has 10 processes. Each process requires 50 horsepower of steam. This equates to a maximum theoretical steam demand of 500 horsepower. The original engineer probably wanted to provide a little extra capacity as a safety factor, so he may have specified a 600 horsepower boiler. Now let's look at the customer's actual steam demand. Yes, the customer originally had 10 processes, but maybe they discontinued or removed 2 of the processes. Of the remaining 8 processes, maybe they only actually operate a maximum of 5 processes at any given time. 50 horsepower per process multiplied by 5 processes, this equates to a maximum demand of 250 horsepower. By sizing the boiler room based on their actual demand instead of their theoretical demand, we can significantly reduce the size of their boilers. Now let's look at a couple of different load scenarios. In case number 1, 5 processes operate at any given time. As one process turns off, the next process turns on. This results in a relatively steady steam demand as shown in the graph. In case number 2, the processes turn on and off as needed, but in a less controlled fashion. Again, the maximum processes operating at any given time is 5, but there are also times when only one process is running. This results in a cyclical load pattern as shown in the graph. Let's compare the 2 load profiles. Again, case 1 is a steady steam demand, and case 2 is a cyclical load demand. In both cases, the maximum load is approximately 250 horsepower. In case 1, however, the minimum load is approximately 200 horsepower, whereas in case 2, the minimum load is approximately 50 horsepower. This is important because we need to take into account both the maximum load and minimum load when sizing the boiler system. In both cases, we could sell the customer 300 horsepower, but in case number 1, we could recommend one LX300 boiler, whereas in case number 2, we could recommend 2 LX150 boilers. By better understanding the customer's load profile, we can size a Miura system that fits their needs. Note, if the customer has dedicated gas meters or steam meters installed on their existing boiler, then they may already know their steam demand. In these cases, they can simply provide us their data, and we can analyze the information in order to generate the proposal. However, many customers do not have this information. In these cases, it would be beneficial to perform a load study. What are the benefits of performing a load study? 1. We can size a Miura boiler system that better fits their needs. This ensures that the new Miura boilers will operate as efficiently as possible under the actual loading conditions. Also, performing a load study allows Miura to establish a relationship with the customer. We may not sell them a Miura boiler right away, but by providing them with this valuable information, we hope to establish a relationship and gain the trust of the customer. Thus, when it comes time for the customer to replace their existing boilers, we have already established the relationship with them. How do we perform a load study? The load study utilizes simple non-invasive sensors to allow us to install the equipment without significantly disrupting the operation of their existing boilers. The necessary equipment is comprised of two simple sensors. 1. An angle sensor. The angle sensor is installed on the boiler's gas valve linkage. By monitoring the angle of the gas valve, we can estimate the firing rate of the boiler. The second sensor is a clamp-on amperage sensor. The clamp-on amperage sensor is installed on the boiler's main gas shutoff valve. By monitoring the amperage to this valve, we can determine when the valve is open and when the valve is closed. Therefore, we can determine when the boiler is firing and when the boiler is in standby. Once the sensors are installed on the boiler, we need to calibrate them. It is important to note that for this process, we need the customer to manually adjust the firing rate for a few seconds. We need them to run the boiler into low fire, and we need them to run the boiler into high fire. This process should only take about 30 seconds, so it should not significantly affect their steam supply. Typically, we will study their boiler for approximately 2 weeks. This usually provides enough data to see the maximum and minimum loads during normal day-to-day operations. Note, it is important to consider the customer's process when scheduling the load study. If the boilers are used for building heating, then we would want to study the load study during the winter months, because this is the time of year when the heating demand is the greatest. After the 2-week load study has completed, we will remove the sensors. Once ESDG receives the data, it typically takes about 2 weeks to analyze the numbers and generate a report. What is included in the report? The load study report is a simple document that displays the corrected data that was gathered during the 2-week study. The graphs that show the daily load profiles are the primary takeaway from the report. Using these graphs, you should be able to identify the maximum and minimum steam demand. So let's review a few points. 1. A load study is exactly what it sounds like. It is a study of the customer's steam load demand. A load study is not an efficiency study, so it should not be depicted as an efficiency study. The customer needs to understand that we are simply monitoring the firing rate of their boiler in order to estimate their steam demand. 2. By performing a load study, we can better understand the customer's load profile. Using this information, we can size our equipment to meet their demands in the most efficient and cost-effective manner. Finally, the load study allows us to establish a relationship with the customer. This is a valuable tool for building the relationship and trust with the Miura name.